stop to 1 second. As I said before, this this video will be available in a few days in the 5G Med YouTube channel. So now let me share my screen, and you will see in a few seconds you will see my screen with the presentation. Okay.
Do we have to share our screens when we?
No, I will take care of that. I will take care myself of that. Remember to, if I didn't follow your speech, remember to tell me to change the slide. I will be really attentive. But yeah, I will take care of that. It can be a bit slow due to the connection. If you, I would ask you maybe to take off the camera. The person are not presenting right now, so I think that it will maybe help to do it better, or you can let the camera on if you feel that everything is going well. So hello and good morning, everyone. Thank you for being here today. It's a pleasure to share this hour with you. We have a lot to share about 5G Med. You probably know already the project. We will not enter in detail to present what we are doing, but we will explain you some technical aspects, some challenges that now we hope we are gonna be able to separate. So this is the webinar session, Connectivity Beyond Limits in Mobility Cross-Border Scenario with 5G. And the agenda would be the following. We will start with an introduction by Christian Micas, Senior Policy Officer, DG Connect European Commission. We will continue with a presentation, a short presentation of José Lopez, the Project Coordinator of 5G Med and Innovation Project Manager from Cellnext. And then, of course, Francisco Vázquez Gallego, and I for sure didn't write well your name again. I'm sorry, Francisco. He will present the technical challenges. He's a technical manager at I2CAT. And we will go through the different use cases presented by each use case owner. It will be a short presentation. So if you want to have more information about each use case technical aspect, you can write us on the chat, and we will read your question and ask the use case owners to answer after the presentation. We also have we are also really lucky because we have people from 5G Blueprint, and I hope people from 5G Rail also that will talk about also a bit the technical aspect of the project, and we will see how we can find some synergy entre all the project. I don't need to remember you that 5G Med is part of the ICT 53 project, so this is why we also invited 5G Blueprint and 5G Rail to be part of this session. So please, Christian, Mika, if you can start with your presentation.
Yeah, many thanks, Marjorie, and ladies and gentlemen, dear colleagues, good morning. First of all, many thanks to 5G Med for your invitation. As a matter of fact, I happen to be also the project officer for the 5G Med project. So I would like to give you very rapidly a European Commission perspective on 5G corridors, reflecting on where we come from with large-scale cross-border trials to where we're going to with pan-European deployment of 5G corridors. Indeed, 5G Med belongs to a large wave of 5G cross-border trials funded under Horizon 2020 that you can see on this map. It's not all of them, but so this project indeed aims to demonstrate a 5G-enabled connected and automated mobility use cases, including rail or on ports, inland waterways, in various locations of the EU. These results will be key in order to prepare for the large-scale deployment of 5G cross-border corridors. The vision from the Commission is, first of all, that 5G is a key enabler for connected and automated mobility. The vision is to ensure a pan-European networks of 5G corridors, mostly along the 10T corridors for connected and automated mobilities. We expect this deployment to be mostly driven by the private investment and with some dedicated funding instruments, and in particular, Safe Digital's goal is to leverage this private investment, in particular on cross-border section of corridors. These visions belong to the Digital Decade Policy Program, and it is operationalized on the basis of multi-country projects whereby private and public resources are pulled together under the coordination of the SNS joint undertaking and on the basis of a 5G strategic deployment agenda for the provision of guidance. So to cut a long story short, I would say that already at the beginning of this year, the first wave of self-funded deployment and inception studies project were kick-started at the beginning of the year, and I will show you in a moment a map of this project. A second call has been launched, and the results will be published towards the end of the year after the signature of the grant agreement. And of course, I would like to draw your attention on a third call that has been launched on the 17th of October, and that will be open until the 20th of February next year for the preparation of a proposal for deployment works and exemption studies. The budget for this third call is 100 million euros with intervention rates up to 50%, as the priority is on cross-border section of corridors. We expect the proposal for deployment works to rely on the call one exemption studies, but I mean, works proposal based on other studies, of course, can be submitted as well. I would like to also come back to the role of the Smart and Network Services joint undertaking that has been formally tasked to coordinate a strategic deployment agendas that will be also quite instrumental in order to support the safe project pipelines and provide guidance, in particular regarding the deployment scenarios and the cooperation models. So next slide, and I will stop here. I would like to share with you on this map, you see the 15 safe digital projects of call one. In orange, we have the deployment works project, and in green, the inception studies project, whose result will be certainly quite instrumental for, we hope, the preparation of call three proposal. Perhaps very rapidly, and I will end on this to share with you a typology of the different investments models as we see them. We have in the southern part of Europe, you can see in particular Evocam, Iberian 5G, Natcore 5G, and Medcore 5G, a number of projects that are focusing on the deployment of passive network infrastructure that will be provided on the basis of a neutral host model. This is something that is also quite on which 5G Med has been working. We see also a number of projects that is, on the contrary, focusing on the other end of the 5G corridor value chain, if I may say so, with 5G Deluxe and 5G Single, which aims at the provision of seamless cross-border deployment solutions based on investment in the active layers of the 5G corridors. So this is for it. Enjoy the webinar, and do not hesitate to contact us whenever you would have questions regarding Safe Digital, of course. Many thanks for your attention.
Thank you very much, Christian. And I'm actually very happy to see that both cities where I was, the city where I was born and the city I spent a lot of time, Mulhouse and Karlsruhe, they are also working on something. So it's really nice to see it. So let's continue with José Lopez Luque presentation, the 5G Med project coordinator. Please, José, you have.
Thank you, Marjorie, and thank you, Christian, for your opening, and everyone for being here in this webinar. So, as Marjorie introduced, I'm the project coordinator of 5G Med, and first I will give you a high-level overview on the project, the corridor, and the use cases, and then we will go deeper into technical aspects with Paco's presentation. So you can continue, Marjorie. I think one slide should in between before this one.
No.
Okay. So yeah, this is a thumb of the 5G Med corridor. As you can see, it's starting in Figueres and ending in Perpignan. This is around 50 kilometers of corridor. And the very special thing of 5G Med is that we are covering both railways and road with the same infrastructure. So we have deployed, or almost the same infrastructure. All the 5G network we have deployed is both covering the road, the highway, E9 European highway in our case, and the railways, okay, including an 8 kilometers tunnel under the mountains, which is called Leopard 2 tunnel. Next one. So yeah.
It was inverted, no?
This is the one I was missing.
Yeah.
It's fine. So yeah, the objective of 5G Med is to demonstrate CCAM mobility in the cross borders between different countries in the European Union, and also to enhance railway mobile communications to improve different services for the railway operators, for the passengers. As Christian was saying before, this is an EU-funded innovation action from the program Horizon 2020 and ICT 53. And we have a budget of almost 16 million euros. This project, so 21 different partners are collaborating in this project. And we have very different kind of partners, from mobile operators, neutral host, railway operators, innovation centers, road operators. So a really rich ecosystem. And from 7 different countries in Europe, as you can see here in the map deployed. And the project started in September 2020, and it will end next year on the 31st of August of 2024. Initially, it was a 3 years project, but has been extended 1 year. So now we have a 4 years project. Now I will give just a very fast overview, an introduction of the 4 different use cases that the network we are building is supporting. And later on, the use case owners will go a bit deeper on each of the use cases. Use case 1, it refers to remote driving. In this case, we have like an autonomous vehicle on the highway. And if something happens to this vehicle and cannot continue with the autonomous operation, then the project shows how we can remotely take the control of the vehicle and drive it to a safe location. As you will see later, to have inter-PLMN handover between 2 countries is very important for this use case, so that we can drive seamless from one country to the another in the cross-border. Use case 2 is about road infrastructure digitalization. Here we are using different technologies from cameras in the highway, roadside units, and also 5G network, so that when a car detects an obstacle, for example, can send alert message to the cars around in the area, and these cars can can change the lane, can adjust the speed, so they can adapt in advance to the situation of danger. And in this way, we can avoid traffic accidents, and also we can reduce pollution when adapting this because of the mobility strategies. Use case 3 is the most complex use case, I would say, because it has 4 different sub-use cases inside, and it's dealing with things like also obstacle detection, but with the train, with a LiDAR. It's dealing with IoT sensoring for all the operation of the train to improve the efficiency of the operation for the railway operator. It's also providing high bandwidth internet access to the passengers, both with Wi-Fi access point connected via 5G to the outside, or also directly the passenger can be connected to the 5G with an onboard small cell that we have in the train. And last, use case 4, it's called infotainment use case. And this is both for the railways and for the automotive sector. Basically here we can share like entertainment applications. We can watch a video on Netflix, for example, together with, while we are in the car, together with a friend that is at home sitting on the sofa, and we are totally synchronized. When we stop the video, our friend at home, his video will also stop. And another very special thing about this use case is that we are using MEC, edge computing, and when the user is moving, we also change the server so that we can assure always the low latency of the contents we provide to the application. Next. Yeah, and finally, this is a very high-level project time plan. As I was saying, we are almost at the end of the 3rd year. We have 9, 10 more months to go. And just a couple of weeks ago, we had our 2nd project demo in the cross-border. We were showing all these use cases I have described working, or not everything, because everything will be shown in the final demo scheduled for June 2024. But many things were shown already in the demo we had a couple of weeks ago. And as you can see, basically the network deployment is finalized, and now we are focusing on more testing on the use cases and also business exploitation, dissemination activities, etc. So yeah, that's my final slide. Thank you, Marjorie, and everyone.
Thank you, Jose. Now we will continue with Francisco Vázquez, the technical manager of the 5G Med project. Please go.
Yeah. Hi. Good morning to everyone. I think that okay, these are the last version of my slides. Can you go through them just one moment, because yes. Yesterday I did small modifications, and I was wondering if you had integrated this in this final slides. Okay, thank you very much. So we go to the first one, and we can start. First of all, good morning to everyone. It's a pleasure to share with all of you all the technical achievements that we did in 5G Med so far, especially the results that we got in the demo a couple of weeks ago. It was amazing. I will start my presentation describing the main goal of 5G Med and the technical objectives of the project. Then I will briefly go through the technical challenges that we are facing in the project. And finally, I will explain some of the key technical achievements that we have reached so far. So if you go to the technical objectives, the main goal of 5G Med is to evaluate the capabilities of 5G technologies to meet the performance requirements of connected and automated mobility services and use cases in cross-border scenarios. To this end, we have defined 4 main technical objectives in 5G Med. The first is to design a cross-border 5G Med network architecture to guarantee seamless service continuity when connected vehicles cross national borders. The second objective is to use this 5G network architecture design. Using this 5G network architecture design, we have to deploy 2 5G standalone networks that provide coverage to our Mediterranean cross-border corridor between Figueres and Perpignan, these 50 kilometers of segment that we have in 5G Met. The third objective is to develop and deploy the 4 different use cases that Jose has already introduced before. We have these 3 vehicular use cases to be demonstrated on the E15 highway and 1 railway use case to be demonstrated on the high-speed train, the French TGV. At the end of 5G Met, we have to conduct trials to evaluate the impact of cross-border roaming on the key performance indicators of our use cases. So let's go next to review which are the main technical challenges. In a cross-border scenarios where connected vehicles move across neighboring 5G networks, the provision of uninterrupted and reliable CAM services entails a number of technical challenges. The first challenges are related to the use of legacy roaming mechanisms. In this sense, the existing home-route roaming mechanisms, which is typically used in all commercial cellular networks, has 2 important drawbacks. The first is that it is introducing very long interruption times, so we can have interruption times within 1 and 2 minutes, and this is absolutely unfeasible for connected automated mobility. We cannot provide seamless service continuity with these 2 minutes of interruption. As an example, if we have a connected autonomous vehicle that is being teleoperating, it will automatically stop when we have an interruption time that is above 100 milliseconds. So the first challenge that we have in 5G Met is to implement roaming optimization techniques that really help us to substantially minimize the interruption times. Another problem of this home route roaming is that when the user equipment connects through the visited network, the latency really increases. So what we have to do in 5G Met and in other projects that are running in parallel to 5G Met is to use and implement local record roaming so that we can minimize latency when we are connecting to the visited network. Another important aspect that we find in cross-border scenarios is that normally each mobile network operator is using its own domain orchestrator. This is perfectly fine when connected vehicles move within their home networks. However, when they are moving, crossing national borders, we must ensure that the required services, slicing and computing resources are completely ready and available when the vehicles connect to the visited network. In order to overcome this challenge in 5G Met, we have to develop the required cross-border interactions between the orchestrators that we have in the 2 network operators. So let's take a look at the and this is not the last version, but anyway, let's go to the achievements. Yeah, I can see now that they did some other improvements or, yeah, okay, anyway. So let's go to the achievements session. The first achievements that we got so far in 5G Met is the design of this 5G network architecture for cross-border scenarios. This is our 5G Met network architecture. I will not go deeper into the details here. The idea is that this is an architecture divided in 6 functional layers with 3 cross-border interfaces. Network infrastructure layer that you can see at the bottom of the figure includes radio access network, transport network, and the 5G core networks in each of the countries. Here we have implemented a cross-border interface with both home route roaming and local record roaming mechanisms, working with different types of optimization techniques to minimize the interruption times. So here we are including the N14 interface between the AMFs of both 5G cores, and we are also including the radio handover between the G-Node that we have in the border. I think it is important to highlight that in the 5G Met architecture, we are integrating MEC federation to enable the transfer of information between application instances that are running in the mix of different operators, as well as the federation of the orchestrators based on this east-westbound interface of the operator platform by the GSMA. We can move to the next slide, Marjorie. Yes, okay. So then regarding the 5G network deployment in the corridor, we have deployed 2 complete 5G SA networks operating in the N77 and N78 frequency bands. We are using Druid 5G cores, 1 core for each of the 5G SA networks. In total, we have 11 GNOT-Bs up and running, with 6 GNOT-Bs of Ericsson in the Spanish network and 5 GNOT-Bs of Nokia in the French network. In addition, we have deployed 1 GNOT-B with a distributed antenna system of Nokia to provide 5G coverage inside the railway channel that we have in Leopard 2, crossing the Pyrenees. And regarding this crossing the Pyrenees, you can understand the complexity of this of the orography in this mountain area. It is super complex and irregular, so it really creates a lot of difficulties to get a good radio overlapping between the cells in the border. In addition, the deployment of the transport networks to connect the 5G RAN and the 5G cores that we have in the village of Leopard 2, so we had to implement here complex multi-hop microwave and fiber links to get this connectivity. So let's go to the last slide about the technical achievements. This is about the results that we got in the network-specific tests and trials of 5G MED. We did several experiments to measure 5G network APIs along the corridor, and of course, crossing the border. So we had to measure the evolution of our latencies, our throughputs, and interruption times when we were doing roaming. In this slide, we're just presenting the preliminary results that we got for the interruption time measurements. We obtained this some weeks ago, just before the demo to the European Commission a couple of weeks ago. So the interruption times that we obtained so far, including this N14 interface and also this radio handovers between the GNOT-Bs in the border, is between 90 milliseconds and 100 milliseconds of interruption. So with these preliminary results, we can already conclude that we have demonstrated that our roaming optimization techniques, already fully implemented, are good, and that we can meet these strict requirements of our 5G MED use cases to guarantee service continuity, and especially in the remote driving use case. And that's all from my side. Here we have some pictures of the demo days, but yeah, I was expecting to have this in the presentation of the use cases.
Yes, I think that it was important for everyone to see a bit what was done in each use case. Of course, each use case will now present their own use case, but I thought that it was nice to share with you some picture and some moments of those demo days. Yeah. I think that it's important now that a question would come at the end of the session, and to ensure that the session is quite dynamic, please respect the 5 minutes. So Kevin and Nguyen, use case one owner, if you can start with your presentation and really try to stick to the 5 minutes so everyone can talk. Okay.
Yes. Hello everyone, so thank you for your attention, and I will respect the 5 minutes. I only have 4 slides. I will start by an overview of the UC1, the remote driving, focus on the cross-border challenges for the remote driving itself, and unfortunately I do not have the slide that you have seen before with the picture, because I haven't the slide, but we will talk about the next step of the demo done in few weeks ago. So about the use case 1, just to remember you, so thank you, Paco, once again, you have introduced it already. We are in autonomous mode, and this autonomous mode will have an issue, which will imply to remote drive this vehicle to safer board. Over here, you can see a very simple scheme about the MNO1 and the MNO2, and we will have to proceed the roaming to bring back the car to a safer board. And during this operation, we'll have several figures that we have to meet to succeed the roaming via auto operation. Okay, just one thing on this slide. So we are developing a value teleoperation cloud. So it's a public cloud connected to the 5G MED network to manage teleoperation here at Valeo. Okay, can go to next slide. So a very simple view. So I do not have the very recent pictures that you had, but I just kept these pictures to show you. So, okay, we have a remote vehicle, which is at its basic an autonomous level 3 vehicle, which has been used to modify the control of the vehicle and be a teleoperated vehicle. Then in anywhere, so it was at the LFP, but it could be in Paris or in Barcelona. We had this remote station in which we have a main view to teleoperate. So I was a teleoperator for this demonstration and the several tests that we have done to teleoperate so the remote vehicle, and we did a demonstration so on the highway in Spain, trying to cross the roaming that we have made for the demonstration. On the right, you have only a KPI view, which is also important to follow what's happening on the network, the RSRP, RSRQ, ID cell, the latency, of course, and the data rate. Okay, we can go ahead. Okay, there is some modification on the slide, but whatever, just to tell you very simply what's happening to TOD, teleoperation driving, the same as remote driving. When you cross a border, there is two possibilities. If the handover success, it's seamless, as Paco said, but if not, the vehicle will take back control to keep the passengers safe. What is important over here about the cross-border challenge is about the figures about the latency. So 200 milliseconds at 90 km/h is the maximum latency that we can have for teleoperation. This latency is end-to-end latency, so from the vehicle to the home station. So it's not only network latency, it's included inside. Which should have a minimum of bandwidth, 2 megabytes per second, to ensure the vision of the cameras to the home station. And the last requirement, which not appear on this slide due to the typo or whatever, is a maximum interruption time, which has been said already by Paco. It's 100 milliseconds. If we do not respect it, we'll go into the minimum risk maneuver mode that will lead to handover, a failure of the cross-border. Okay, next slide. My last to keep in the 5 minutes. So few points that we had in mind for the UC1 and for 5GMed for the next several months to the final demo. We had an average of 100 milliseconds. We expect to have less, of course. We try to do several handovers, and we have to reach it to have true demo at the end of this project. And as said by Paco, we have reached 70 km/h already, but we expect to go faster, even if the minimum of speed allowed on the highway is 60. So we are already reached this challenge. Another one which was very important for us, and Jose will confirm it, will be the authorization and the large-scale trial test procedure. I mean, the segregation lane and everything else which allow us to test and perform a good demonstration. So we'll have to manage it, and it's very complex. And the last point is to add new features. So I will explain it later, but we could expect to have the vehicle keep in lane, for example, when we go to a high speed to ensure safety. I think it's 5 minutes now.
Yes, perfect. Thank you, Kevin. Let's continue with use case 2 presentation. David Porcuna from Autopistas, please. Sorry, your mic is
Sorry, I was mute. Good morning to everyone, first of all. So to be strict with the 5 minutes, let's skip this first slide and this, and let's go to the point. Okay, As Jose has introduced before, use case 2 deals with how to improve traffic flow and safety on highways with cross-border scenarios, taking advantages of what a 5G communications network can offer. In use case 2, we'll demonstrate 3 services. The first service is called Relay of Emergency Messages. Here, an obstacle in the road, like the yellow stopped car that you can see in the diagram, is detected by the connected vehicles that are passing by. The information of the obstacle is then sent to a local traffic management center, the TMC Edge, at the next server of the 5G network. Then this TMC Edge automatically sends a warning message and traffic recommendations to the connected cars approaching, even to those ones who are about to cross the border. And the second service, automatic incident detection, is quite similar, but here the obstacle detection is made using video cameras placed along the road instead of the cameras inside the vehicles. The final service, service 3, traffic flow regulation, consists of a TMC global that, using information provided by different local TMCs under its coverage, is able to generate strategies that can regulate safety and traffic flow by sending recommendation to the connected vehicles. And this effect is also multiplied by the fact that the conventional vehicles, the ones that are not connected, would add in maintaining those last ones. Next slide, please. Okay, implementing these 3 services that we've seen bring us some challenges. First, how to cope with the service interruption, because we don't want to lose neither hazard information nor traffic recommendations to adapt to what is happening just across the other side of the border. And secondly, we also don't want the service to degrade, especially considering that we are on high speed and high capacity roads. So to address these challenges, 5G MED provides solutions that allow faster reconnection when roaming, such as inter-PLMN and 14 interfaces on improved handover techniques, as Paco has shown us. And we have created also a cross-border interoperable traffic management to facilitate cooperation between TMCs in the 2 sides of the border. And we have also worked in continuous dissemination of hazard and traffic recommendations for all the connected vehicles in the area. So next slide. Okay, so during the last week of October in the cross-border area between France and Spain on the E15 highway, we've demonstrated some achievements that we have made so far. The first one was a static demonstration of functionality of Service 1. And here we use 3 vehicles parked in the service area on La Jonquera to demonstrate the detection of an obstacle in vehicle 1 and the dissemination of the hazard to the vehicles 2 and 3. As we see in the data path diagram, the vehicle 1 detects an obstacle with its camera and transmits a DNM hazard message to the local Spanish TMC. So vehicles 1 and 3 receive warning information directly from the gateways in the Spanish side. But since we are in a home-routed roaming scenario, vehicle 2 is still connected to the French gateway. Thus, the message it receives had made a full path from the Spanish side via the 2 cross-border TMCs to the French gateway, who is the one to connect and sends a message to the vehicle 2. Next slide, please. Okay. The second demonstration we did was more focused on performance of Service 1 KPIs. Here, the 3 vehicles were driving on a road starting in La Jonquera, Spain, then up to the Perpignan in France, and then back to Perpignan in Spain. Again, here in a home-routed roaming scenario, but now crossing the border, we hope the messages, CAN and DNMs, sent by vehicle 1 were received by vehicles 2 and 3. As I said before, the aim was to measure the KPIs affecting the service. In the lower left corner, we can see the Grafana dashboard we used to collect all those measurements. We can see the main KPI. Okay, you can see here some peaks indicating some interruption times that we have to deal with. And we also see the physical cell ID that shows in real time the real cell the vehicles are connected to that help us to situate and allocate those vehicles. So next slide. Okay. We've been seeing some glimpses of what we have done so far, but what comes now until the end of the project? First, we need to use local breakout instead of home-routed roaming and other roaming optimization techniques to reduce this service interruption time when crossing the border. We also need to fine-tune the synchronization between devices. We have many devices inside the vehicles. We have also the gateways, the TNC edges, the TNC globals. We have to do a fine-tuning on the synchronization of all those elements in order to get good measurements. And we also need to reduce processing times to get closer to the KPIs targets that we have in the project. And finally, we have to deploy cameras for the traffic automatic analysis that will allow us to demonstrate services 2 and 3. And this is all from my side. I'll leave the floor back to you, Marjorie.
Thank you very much, David. Let's continue with Juan Agustí. Please. Your mic is mute, and this is the time that I need to tell you to stick to the 5 minutes, please.
Okay. Good morning. I try to be considered these 5 minutes. Even this use case is really complex.
We know.
Start with a brief overview of the use case. After that, we take a look on the cross-border channels, and after that, we go to the next step in the use case, please. Okay, then we have 3 main aspects in this use case. The first one is to develop railway services of kind of performance services with a sustainable amount of network resources needed to work with this. The second one is development of the concept of the gigabit train concept to support passenger services, simulating a train this full of passengers. And finally, the objective is to provide seamless services with a quality of services similar to what you can get at home. Okay, we are all the time looking at the calls inside the trains for the passengers are good with tunnels, orography, and this kind of obstacles. Okay, then the use case is composed. No, please, Marjorie, go back to the first one. Okay, we have 4 services to demonstrate this, to showcase how is this. The first one, there are 2 related to performance services, another one related to passengers. In the case of the performance services, what we have is a massive IoT simulator built by SNCF that includes around 4,000 sensors inside the train. And a second service is about obstacle detection using a LiDAR in a very accurate mode. Okay, and for passenger services, what we have is a high-performance internet access Wi-Fi with Wi-Fi 6 inside the train, and a proof of concept of a really interesting model about to provide in-train MNO service with a small cell inside the train connected to private 5G core to provide in this way MNO services to the passengers. Please, Marjorie. Okay, then the other part is to ensure this seamless experience. What we do is use 3 complementary technologies at the same time. The both 5G standalone networks of the 5G main network, but also we use 2 specific technologies for the railway. One is the 70 GHz networks in the Spanish part of the corridor to demonstrate the gigabit train concept, and also complement with satellite in both parts of the country. To combine this, what we use is to use a multi-connectivity gateway developed from scratch, okay, in order to accommodate the best access network to each service in each moment, right, with predefined rules. Finally, we showcase these 4 services in 2 kind of trains. The first one is a maintenance trains coming from LFP at 90 kilometers per hour. That is what done previously in the test, in the demo. And what is next is the TGV of SNCF at maximum speed that will be demonstrated this year. Okay. Okay. Then, in the case of the access network technologies deployed, we have the 5G networks. We are able to correlate information of the network with the service KPIs that we have. And we use these 5G networks combined with the highway at the same time. Okay, but also the satellite network is deployed. Okay, in this month you can see here to provide full coverage, except in the case of the tunnels, with a committed information rate about 10 megabits. And also we have 70 gigahertz networks, especially deployed for the train that continuous localizing the train, moving with the train with advanced beamforming techniques in order to provide this gigabyte capability. And the previous results that we have shows that we expect what we need is the performance about the gigabyte. As you can see in these numbers, round trip delay of about 20 milliseconds and coverage about the 100% of the track. This one, please, Marjorie. Marjorie? Okay.
Yes.
Then, in this case, what we show here is how this multi-connectivity gets with HOR to perform automatic handovers with the preferred technologies used by each service. Okay, we demonstrate how this gateway performs the handovers with automatic reconnections when we suffer a failure or whatever. Okay, I don't decide to go more on deep on this slide. And please go to the next one. Then the cross-border challenge that we demonstrate are, okay, of course, we have the roaming issue. All the services must work with this seamless experience across the cross-border. We have to perform specific handovers between the different technologies in the cross-border because it is what I explained. Not all of them are available across the whole track. Okay, and finally, we have a group of cross-border challenges related with the LBO roaming that we need in order to accommodate the traffic in the corresponding countries. That is the thing ones that are has to be accomplished with this LBO roaming in the network. And finally, in the case of the small cell in the train, we have to adapt the frequency that is used in each country when the train moves from one country to the next. Okay, then the next steps, Marjorie, to finalize are that we have to complete the validation of these cross-border challenges related with the local breakout roaming. We have to do a performance characterization of the track based on the network and service KPIs. In these ways, we can program automatic handovers with the best performance in each train location. Terminate the service KPI analysis related with all of this. And finally, the most important thing, we have to do the TGV test, what includes the deployment of the components in the train, the tuning of the networks, the validation, and the final testing. Okay, and with this, I finalize my part.
Thank you very much, Juan. And I'm sorry you have to speed up or go so quick. And Rodrigo, you will have to do the same for use case 4. So the floor is yours.
Okay, thank you, Marjorie. So I'm Rodrigo. I'm from Atos, and we are owners of the use case 4. And well, the following infotainment use case integrates multimedia streaming and interactive technologies on top of a 5G orchestrated infrastructure. So the focus in this use case is the demonstration and the performance evaluation of services while experiencing MEC migration. So we are providing a set of infotainment applications to showcase the edge-to-edge migration. So we have 2 services in UC4. One is the Enjoy Media Together service, which is developed by Atos, and the second one, which is the tour planning service. These services are developed with functionalities that require very low latency values and a high throughput. So the aim in this the cross-border scenario is to maintain the continuity of the services, to maintain the session and to be seamless for the user. So could you go next slide, please? Thank you. So this is how we map the services into the 5G MET architecture. The services are divided in 3 layers: the edge layer, the cloud layer, and the client layer. The client layer will be the user operating the service, and the edge layer is the one that we are aiming to migrate from point A to point B, in this case, France. As you see here in the architecture, if the user is moving left to right, it will be moving from France to Spain. And at this point in time, we, the MBC has developed an MNO communication. It's called Edge Federation that Paco mentioned before. And this will enable the edge layer of the services to be migrated from one country to the next country. Thank you. So what we found during the demo days is that the service continuity is in some location of the network is cut for different reasons. The main is that the network is not able to provide all the requirements that the services are. Just remember that these services are very high demanding, and in some points of the network we experience these cuts. Also, the Edge Federation is a very another challenge that we are taking advantage of in this use case of the API that MBC has developed. Also, well, if you move next, our next steps are the integration of the components to attain an automatic deployment. So in this case, our aim is to attain a migration completely automatic from the point of view of the user. So it will be consuming the application from one edge, or if it's in Spain, from the Spanish edge, or if it's in France, from the other edge. And for that, we need more testing. And that concludes my presentation. Thank you.
Thank you very much, Rodrigo, and thank you all, Use Case Owner, for this presentation. I know that I asked really to be quick on that, but it's because we also invited other projects. As I mentioned before, 5G MED is part of the ICT 53. So that's why we invited today 5G Blueprint to present us also the technical aspect of the project, and maybe to talk later on the synergy. I know that we are having now doing more than an hour, and I'm sorry if you have to leave the webinar. Don't worry, it will be uploaded on YouTube channel. Okay, Nina, the floor is yours.
Thank you very much, Marjorie, and thanks a lot for inviting me to present 5G Blueprint achievements. As introduced by Marjorie, I'm Nina Slannik-Kreštarec from 5G Blueprint, and today I will show you some of the advancements we made on the seamless roaming in 5G Blueprint to enable cross-border teleoperation. Just to start quickly with an overview of the project and use cases, I will not go into details because of the time constraints, but I will focus a bit more on the seamless roaming and what we learned so far. Concerning, next slide, please. Concerning the project, as it is another ICT 53 project, a sister project of 5G MED, we focus also on the 5G standalone release 16 deployment in different pilot sites. And apart from the cross-border one between Belgium and the Netherlands, We also have 2 national pilot sites that were developed first to test different use cases in this real-life environment of 2 ports, Port of Antwerp, Bruges, and also Port of Vlissingen. In this very diverse ecosystem based on 5G standalone, we have different user equipment depending on the use case. We worked with cars, trucks, reach takers, and also barges to really have a broad scope of different optimizations in transport and logistics chain. Then, of course, 5G Release 16, new radio and core infrastructure, and concerning data network, we also, in 5G Blueprint, we developed different enabling functions that are enhancing the capabilities of teleoperation use cases. Most of the use cases that we work on in 5G Blueprint are teleoperation ones. We teleoperate trucks, vehicles, vessels, skid steers, but we also need some additional situational awareness through the application layer with these enabling functions like intelligent traffic lights that are optimizing the maneuvering for the teleoperated vehicles and barges, and also increasing awareness of vulnerable road users and providing estimated time of arrival to further optimize the arrival time, etc., etc. I will not go into details of any of these, but I invite you, of course, to read the deliverables and also to reach out to us for more information if needed. Next slide, please. These are the 3 pilot sites that we developed. I already mentioned that we have 3 distributed geographical sites, 2 in the national sites, basically 1 in the Netherlands, 1 in Belgium, and 1 on the cross-border side. And depending on the use case, we do different piloting activities. In the cross-border one, we actually teleoperate barges and vehicles while crossing the border, while in the other 2 sites, we also tested the same use cases, but in addition to that, in a port environment, we also tested automated docking and teleoperated crane. Next slide, please. And very briefly about use cases. I also present here on the next slides some of the results we achieved so far, and these 4 use cases are developed by different partners who are tirelessly working all these years on the 5G blueprints to enable the technology for teleoperation, of course, but also to test that technology over 5G. The first use case is on the automated barge control, and then the second one is on the automated driver in loop docking, while third and the fourth use cases are entirely focused on the teleoperation of the trucks and cars, whether they are standalone or in a platoon, where the first vehicle is being teleoperated and then the rest of the platoon vehicles are being either driven by the human drivers or in future driven autonomously. Just maybe a quick recap of all of them. This is about the use case 1, which is the barge control. This use case has been tested in Antwerp pilot site mostly, where we evaluate the capabilities of 5G standalone in comparison with 4G, which is currently used by the company CFAR that is developing this use case. They're using 4G in their day-to-day operation, the remote control of the barges. But in this project, they evaluate the capabilities of 5G standalone and non-standalone and compare the robustness of that connectivity, and especially when moving to the cross-border site, to really leverage the 5G seamless connectivity cross-border to do the remote operation in an uninterrupted manner. The next use case is on the teleoperated docking. Of course, we first started with small-scale simulations in the very beginning of the project, but then we moved to the pilot with the real trucks, and this has been already demoed this year, and in particular in May when we had one of our technical reviews. And of course, now for the preparation for the final event, we are inviting you all to come and see this moving in live and in person over 5G standalone. The next slide shows some of the results we achieved. I just want to highlight that we are, apart from measuring network performance and how is 5G affecting the operation, the teleoperation in this case, we are also measuring different service KPIs that are really use case specific. In this case, for this and also for the next two use cases, we measure the accuracy, different accuracies of the steering and braking, which are crucial for the teleoperation. And of course, we make some kind of connection between the 5G performance and those service KPIs and try to learn how these service KPIs are being affected by the connectivity. All of that, of course, will be presented in the final deliverables, including this one with the steering and braking accuracy for the truck. So we don't need to play, I think, the video for the sake of time, but I will definitely invite you to check out our videos that we publish on the YouTube channel as well, to show how the whole setup for both teleoperation of trucks and cars is working over 5G standalone, and then of course for the barges as well. Yeah, and the next slide shows the same for the cars. Yeah. Again, the same set of or a similar set of KPIs, service KPIs are measured for this use case as well. Of course, the reference values change because of the size of the teleoperated vehicle, but all the tests were done in the real life environment of the port in different locations, of course. And now, when we tested the technology working over 5G standalone, we have been doing many tests on the cross-border side to ensure the teleoperation is smooth or while crossing the border. In the next slide, please.
Yeah, sorry, I just had an issue with.
No problem.
Yes.
So for the seamless roaming, we are very happy to say that already in May this year, we were able to actually show the teleoperation being enabled across the border as well. We tested the seamless roaming and based on the solution that was developed in the project, and to the best of our knowledge, this is one of the first practical implementations of seamless roaming using 5G standalone. Well, in this case, we have done the network evaluation so far with some successful seamless roaming demos in May already. At this point now, when we are in November and getting close to our final event, we are also happy to say that the teleoperation of trucks and other vehicles has been also tested with this reduced interruption time over the border. In the next slide, I will give you a bit more details on how the system works. So in this case, our colleagues from TNO in particular, with very close work with us from IMEC on the network evaluation, and then also, of course, two telco operators, KPN and Telenet, worked hard on testing the solution and making sure that indeed it is safe for the teleoperation to be performed over cross-border. In this case, the highlight of this solution is that it combines home routing with N14 based routing. Of course, this requires further optimization compared to home routing and N14, because we tried to reduce the number of messages that need to be exchanged between core functions before the handover happens. And in case of N14, we exchange the PDU session data prior to handover over N14 interface to make it basically to reduce further the interruption time. And with some other optimization in terms of communication between two SMFs and then AMF and SMF, which I invite you to read more details in the upcoming deliverables, we reduce time that is needed for the whole handover to happen. Of course, to highlight, it is important to say that there is no new PDU session established. The PDU session is maintained in this case, and roaming behaves very similarly to a normal handover procedure. On the next slide, we show some of the results we achieved earlier this year, with basically where the latency, of course, depends on the latency between the cores. Now, if you click a bit, you will also see the results popping up. Before testing anything in the pilot site is basically on the border between Belgium and the Netherlands, and you can see the route which is basically taken to test the setup. With the lab results prior to that, colleagues from TNO have set up have created a setup with 2 core instances and the radio sites coming from the 2 operators, and the lab results do not differ much from the pilot results, which we were very happy about. So if you click again, the field results we achieved show that this handover based on N14 is on average 100 milliseconds. We also have achieved after those measurements also below 90 milliseconds, and further optimization is being done to also include different latencies between the cores and how it is impacting. But so far, the latency in the setup that we have is creating a small impact compared to the other latency components. Apart from measuring only the interruption time, which is indeed crucial for teleoperation, we need to have it lower than 150 milliseconds to have an uninterrupted teleoperation cross-border. We also need to measure uplink throughput and latency and reliability of the connection. And in this case, of course, we focused a lot on the uplink because we are transferring camera streams over the network to the teleoperation center where the teleoperator is operating remotely. So in this case, we're optimizing further the whole setup, both on the radio and on the core. And in 1 month from now, we are going to release many deliverables, final deliverables from different work packages that will show you all the results we achieved, with also taking care of the statistical significance of those results. I will now just give a brief summary of what I presented today, and then also some lessons we learned so far. So as you could see from the slides I presented, we did test auto-docking and teleoperation of vehicles and barges in the national sites very successfully, with KPIs, service KPIs being achieved. The network testing has happened also on the cross-border side, and now we can also claim that we did finish with the testing campaigns with teleoperation of both vehicles and barges on the cross-border side as well. Concerning seamless roaming, our solution, as I mentioned, combines home routed roaming and N14 interface. No problem. You can skip. Yeah, indeed. And then the service interruption time that we achieved is below 150 milliseconds, which we consider sufficient for teleoperation. Some of the lessons we learned is that despite the advancements on the technology that we make, both on the teleoperation and on the network side, there are still some human factors that need to be included and studied more for the teleoperation to be fully successful. So our colleagues who are developing use cases are working on that now in the final phase of the project. And also with concerning the seamless roaming, there is a standardization potential that was recognized in the project, and also our colleagues are working on that effort to promote further merging of N14 interface with home routed roaming, but also proposing solution for seamless roaming in both directions when going from home PLMN to visit PLMN and vice versa. Something that is still being optimized is the handover decision, which is currently based on the signal strength, and it is quite requires some prior configuration before the handover happens, but this is a lengthy process and it needs to be automated, and also we are exploring other criteria that could further improve the way handover is triggered. Before saying thank you for your attention, I would like to invite you to our final event. On the last slide, I give you some details. It is actually now less than 2 weeks from today, so you are all very welcome to visit us. As said on the slide, the event is free of charge, but we need you to register prior to that. Thank you very much.
Thank you very much, Nina, for this complete presentation. Of course, we will continue to talk with you to find possible synergy with the project. I wanted to finish this webinar session with 5G Rail that wanted to present some slide also. Dan Maddock, please go ahead.
Thank you. So I'll be very short because I thought for 5 minutes you cannot speak a lot about 3 years. So I just have 2 slides. Basically, we have a project which is a bit different because we have a European problem, which is that trains in Europe have a 2G system called GSMR. And this 2G system is becoming obsolete. It's a very good, well-working system. It's implemented on most of European lines. It's implemented, I think it's used by, I would hazard myself to say 70% of the trains in Europe are using this system. But it's 2G, so we have to change with something else. So after quite some work and looking, we have a different problem, which is that we need to have very future-proof solutions, because when you put an equipment in a train, you want to keep it for many years. Ain't going to be anymore 15 years, but at least 8 to 10 years. We came with this FRMCS solution, which is Future Railway Mobilization System, which is a not very fancy name for a 5G standalone mission-critical system. And our problem come from the 2 acronyms, standalone and mission critical, because standalone, I'm looking to you a bit jealous even on some of your achievements, which are really, really good, and we will take a look on them because we will use as much as we can from them. But we have the problem of mission critical, which I will speak a bit more in the next slide. We have obtained dedicated frequencies for FRMCS as we have for GSMR. This one are supplementary. And now we have a plan from the last time we presented it in Lisbon and then Aveiro. Now the big news is that it's now introduced in European law, and we have a deadline for making it operational that for available in 2027. So the project 5G Rail is of course financed by DG Connect, like your projects, and it is a ICT 053 project. We have focused first of all to build the first FRMCS prototypes, especially the onboard equipment that we call TOBA from Telecom Onboard Architecture. But also for the application, because the application are not simple applications, client server, they include the mission critical elements with a client server, mission critical, which is a loose coupling for data with the server in the TOBA box, and a tight coupling for voice with the client together with the application. So we had to build them all. We also had to find some chipsets in our frequencies, which we managed to have. We had a number of chipsets provided by Qualcomm specific for FRMCS in FRMCS 1900 megahertz frequencies. Then we had a huge work, because this worked together with the specification of 5G of FRMCS to agree the right scenarios and the right features from 3GPP and 5G that we need to be able to test the most important application, which are railway application, which is a voice communication, very, very important for us. It's a typical voice because it's point-to-point group calls and emergency calls, which is very different to 112. It's a call where all the trains in the area are involved. Then ETCS and ATO, which are the European Train Control System and Automated Operation Systems. TCMS, which is Train Performance System, Video and Passenger Information Systems, all in this mission critical environment. Then to build the prototypes for both of them. After that, testing them in the lab, including border crossing scenarios. Build having the test cases, test them build the test cases based on scenarios, and then test them in lab, test them in field with real trains in an operational line on the local train in Paris area, and the test track with a train test in Germany. Then we also studied rails and road coexistence, including in a border crossing scenario. If you go to my next and probably last slide, please. We have We have a consortium of 18 participants with railway suppliers, 2 universities, and 2 major associations for railways. One is where I work for, UIC, which represents the railways, and the other one being Unifair, representing all the suppliers that are doing things for railways. We reach our main target, which is to deliver the prototypes. We have prototypes that have been built. They were built with the new mission critical service layer, which is really, really challenging, especially when it comes to border crossing. We have tested them in the 2 labs, and we have finalized them with viral results for finalizing the FRMCS specifications. We are now finalizing the test campaign reports and prepare the project final conference, where all invited is going to be in Brussels on the 7th of December. You're going to see the invitation on the last slide. And the previous last thing to say is that we have received 3 innovation awards that you can see them there. Related to border crossing, it's a pity I didn't realize what this is about. I'll do my specific slides on this one. We are doing 2 models. One is the not very loved the 2UE model, which we will use first, because mission critical doesn't have today a mechanism to do border crossing. There's no interface between 2 mission critical domains. This is under working in 3GPP, and we think we're going to have the solution release 18, and therefore possible to be applied in the European trial that will start in June next year for 2.5 years. We also tested a version of the inter-parliament handover, but over AMF, where we realized 2 of the 3 steps. The AMF handover was done, but because we had only 1 mission critical domain, because we had the problem to do the 2 mission critical parts, and we had 2 physical cores. The second one was considered to be emulated because they had the same IP address, but we managed to get there. What we're missing is so we have the cake, we have the materials for the cream, we have the cherry, but we need to put the cream on the cake, neither the cherry on the cake. So we did 2 of the 3 steps. The critical part was this one, because we used enterprise cores, because we think we're going to use this for railways, because our business case is much smaller, much less features, much less suppliers, much less users. And it was a bit tough to make it work and to open N14 and other things. It was successful in the lab. So we did the 2. And even though I know that the 2US is not really 5G, it is what we want to do in FRMCS. So for us, it was very important to do it. I haven't prepared more because I thought you just want a general information, but I'm happy to answer 20 questions. And I think I'm going to stay in my 5 minutes, even a bit less.
Thank you very much, Dan, for this presentation. Yes, we wanted to focus more on the technical aspect, but we have already overpassed the time. I don't know if we have any question in the assistance. Otherwise, I think that it would be better if we close this session, because it's 1 hour and a half. It was really interesting to see also what was done in 5G Blueprint and in 5G Rail. I think that we did a really good overview of our project, and of course this session has been recorded. You will be able to access to the presentation also. And I don't know, Jose or Paco, if you want to conclude maybe, or to share some word about maybe the final demo, or
yeah. So Paco, do you want to go first?
Well, I didn't think about this. Yeah, so we still have a lot of work to do until the next and final demo in July. But things are really moving forward in 5G Med. We can see that we have many similarities with the work that is being done in other projects, especially with 5G Blueprint. We have obtained similar results in this seamless roaming thing, which was one of the most critical parts of the project. I would also like to thank Dan and Nina for your presentations. Really nice work, really good success in both projects. And I will be, of course, visiting Nina and participating in the 5G Blueprint final event. Thank you.
Thanks, Paco. From my side, well, same as Paco said. So special thanks to Nina and Dan for joining our session. It was really nice and useful for us, I would say, to see the progress you have done in these 2 different projects. And I think we have there are a lot of things we can put in common. We can exchange information, especially towards standardization. I'm thinking with 5G Blueprint, we can push together there. So it was really interesting, and looking forward to seeing more on the 21st of November, Nina. And yeah, and also as Paco said, we keep on working towards our final demo, which will be in June 2024. And of course, you will be all invited. So thank you all.
Thank you, Jose. Thank you, Paco. Just to finish, to close the session, I just want to share with you that in December, we will probably organize a session in which will be focused more on standardization and policy making. And we will also have a session, a part of the session dedicated to networking. So it will be really interactive and really interesting to share with all the partners. If you want to participate in the different calls that Christian, thank you. Actually, Christian, for remember us the date and all the calls that are available. So yes, I will keep you update about the date in December. And yeah, that's all from my side. Thank you very much, everyone. And I will share with you very soon the webinar session and all the information you need to continue to follow our project. Thank you very much.
Thank you, Marjorie. Thank you.
Thank you.
Thank you very much.
Thank you.
Bye-bye.
Bye.
Thank you. Bye bye.
Many thanks. Bye. Bye.
Bye bye, Christian.